Okay, so I welcome you again in this next class of Coulomb's law, where yesterday we have studied that what is Coulomb's law, the statement, and we have studied this formula also, F is equal to K Q1 Q2 upon R square, where we have talked about class 11th concept of gravitational force, also a constant known as gravitational constant in class 11th, but in class 12th we are going to study and discuss today about this K. What does this K mean? Okay, so K stands for 1 upon 4 pi epsilon 0, where epsilon 0 is known as the permittivity of free space. So let us now discuss that what is the meaning of this word permittivity of free space. Okay, so basically permittivity means it represents about the medium. It represents that when the two charges which are kept inside the water, now suppose that if they are kept in a vacuum, so the two positive charges, let me take one illustration here. So we are taking here two different boxes. One box is this, and again one more take, we are taking here one more box here. So we are having this second box, and in the first box let us take the medium. Let us fill this with empty space, nothing is there. This is considered to be as vacuum, so I will just write here that is your V, that stands for vacuum, while in the second one we will fill something like water. We can fill, okay, so let us take the symbolic representation of water as blue color. So I will just put some marks. So here we are having the blue color. Okay, so this is your second medium which is filled with water. So this is like W, water, and first one is for V, that is for vacuum. Now let us place two small charges here. Okay, so let us place two charges here. We can take, like I am having two charges here, so one is positive, one more positive we can take. Both are kept at equal distance. Okay, so both are having equal distance of, like we can say, 1 meter here also. Okay, so distance will be 1 meter. And when we calculate the force between those two, just for example, when we calculate the force between these two, it comes out to be 10 Newton. Okay, in vacuum, when we are calculating the force, the electrostatic force between these two quantities, it comes out to be 10 Newton. Okay, now coming back to this, where water is the medium, so we are placing here again two charges at the same distance, no difference, the same distance. This is 1 meter here also, and we are having 1 meter here also, so no difference, both are having the same magnitude. But when we calculate the force, the electrostatic force at this point, it comes out to be, if we calculate it, okay, it comes out, for example, 5 newtons. Now you can see that the first box, which is having vacuum, okay, vacuum as the medium, means there is no particles, no air, nothing. So vacuum is there. In that, when charges are placed, so here the force is coming 10 Newton. In the second one, force is coming 5 Newton. What is the difference? There is no difference between the distance. There is no difference between the magnitude. Both are having the same charges. Then what is the difference? What is making them different? Answer is medium. Okay, in this vacuum is there, and in this water is there. So how this medium decides? So answer is permittivity. This is the permittivity which decides whether a particular medium will have more force or will have less force. So permittivity plays an important role in the case of electrostatics. Similarly, a term will come in magnetostatics when we study magnetism, that is known as permeability, which will play the same role as played by permittivity in electrostatics. So we will discuss later on. Coming back, so what is the formula here? K is equal to 1 upon 4 pi epsilon. Epsilon naught is the value we have written here. Epsilon naught. Epsilon naught is for free space, that is for vacuum. But epsilon is the representation for any dielectric medium, and this is dielectric medium. We will discuss later on what is dielectric. Then I will tell that what is the importance of dielectric and how it is going to affect your two charges when these two charges are placed inside those medium. Okay, so formula remains the same. In vacuum it is 1 upon 4 pi epsilon naught Q1 Q2 upon R square, while in medium it becomes 1 upon 4 pi epsilon naught into epsilon r. Okay, this is important. This is relative permittivity, which is given by this formula here. You can see k is equal to epsilon r. Epsilon r is nothing. Epsilon is the permittivity of that particular medium upon free space. Okay, so we are comparing these two quantities and we can find the value of k. Okay, so we can place directly here also. So the value of epsilon naught is this: 8.854 into 10 to the minus 12 coulomb square Newton minus 1 meter minus 2. Okay, so this is the difference. You can see that yes, epsilon naught is the permittivity of free space, and this value you will be getting in the exams, but still you should know. So now my question, or you can say one assignment is there. You have to find the dimensional formula for this value. Coulomb square Newton minus 1 meter minus 2. That is your assignment for today. And one more thing, you have to calculate the value of 1 upon 4 pi epsilon naught. That what will be the value of 1 upon 4 pi epsilon naught if we put the respective value of epsilon naught. Okay, so that is up to you. So thank you.